Hey everyone, my name is Monisha and today I'm going to show you my 8th DLIC experiment, that is the application of precision diodes with op-amp. So my first circuit is basic half-wave rectifier. So let's go into LT-Spice and run the simulator. Here my VIN is at non-inverting terminal. Diode D1 is a precision diode. The actual threshold of the precision diode is very close to zero, but it is not zero. It equals the actual threshold of the diode divided by the gain and the operational amplifier. Uh, because this is a half wave rectifier, we will only see rectified output at the positive half cycle. So my frequency is 50 hertz. So let's run this input output. As you can see, only my positive half cycle is rectified. Uh, when the input becomes negative, the operational amplifier runs open loop as there is no feedback signal through the diode. When I'll increase the frequency, let's change it to 5 kilohertz. Change the transient time. Run. So as you can see, my first half cycle is proper. From the next cycle, it's an inappropriate output. This happened because of the low slew rate of OP07 op-amp. So moving on to the next circuit, which is modified half-wave rectifier. So we have uh, diode D2 is in feedback, D1 is reverse bias, and D2 is forward bias. Uh, so when the input is greater than 0, D1 is on and D2 is off, so the output is 0 because the other end of uh, R4 resistor is connected to the virtual ground and there is no current through R4 when the input is less than 0. So let's run this. First 50 hertz, then we'll increase the frequency. We out. I'll have to change this transient. Yeah, so as you can see, half cycle is rectified. So moving on to the next circuit, that is no, wait a minute. Let me show you at the high frequency. Let's take 5 kilohertz. Change this to so as you can see this, the my output is not appropriate. So moving on to the next circuit, which is full wave rectifier. For the positive half cycle of a sinusoidal input, the output of the first op-amp will be negative. Hence, diode D1 and D2 will be forward biased and reverse biased. So let's run this. Just I'll decrease this. Let's run this at a lower frequency first. Output, output. As you can see, the output of a full wave rectifier will be a positive half cycle for the positive half cycle of a sinusoidal input. For the negative half cycle of a sinusoidal input, the output of the first op amp will be positive. So let's increase the frequency. Let's see the higher frequency, 5 kilohertz. Let's check at 25 kilohertz first. So as you can see, my first positive half cycle is appropriate, but half cycle my output is not appropriate. Now increase. Let's increase this one more time. 20 hertz, kilohertz. So as you can see, for first cycle my output is proper, but for the second cycle my output is not so good. Okay, so moving on to the next circuit, which is clippers. First we'll see positive clipper. It is a circuit that removes positive parts of the input signal, and it can be formed by using an op amp with a rectifier diode. The clipping level is determined by the reference voltage Vref, which should less than the input range of the op amp, that is Vref less than Vin. The output voltage has the portions of the positive half cycles above Vref clipped off. So as you can see, anything above Vref is clipped off. For a negative Vref, the output will be inverted. So moving on to the negative clipper, Diode D1 is inverted as we from previous positive clipper, and if in this case, if Vn is greater than Vref, we get Vin at the output, and if Vn is less than Vref, we get Vref at the output. So let's run this, and yeah, so basically if Vn is greater than Vref, then the wave below Vref gets clipped. And if we give Vref as minus 0.25 volt, the output will be inverted. And the applications of op-amp based rectifiers, audio circuits, rectifiers, clippers, clampers, peak detectors. So thank you.